Well, hello everyone, and welcome back to my channel. And today we will work with the problem of insufficient node in the root to leaf path. And so in this problem, we need to delete all insufficient nodes and return the root of the resulting binary tree. And so what is the insufficient node in this case? So insufficient means that we need to check that whether the summation from the root node to the leaf node path is greater or equal the limit number. So the limit number in this case, it is an integer value. So let's check this together by two examples. So firstly, we need to calculate the summation from the 5 to the 1. And secondly, we will check the condition like summation from 5 to the 7. So of course in here like we have the part from 5 to the 1. And let's say we have the limit number equal to 22, for example. And in here like 5, 4, 11, and 1, so it means that the summation from the root to the leaf is like 21, right? It is smaller than the 22. However, let's check this case as well. So generally, we need to delete all of the nodes in here. However, we need to check this part as well. So the summation is like 27. So it means that in here, like we need to retain the part from 5 to the 7. So and it means that in this case we only need to delete one node in here and retain the part. yeah so so you can see that in here like it depends, right? These two nodes, they share the same parents. However, because like we have one child node, it satisfy the condition of greater or equal the limit number. And that is the reason why we need to retain the parents, right? Okay, so how can we have the solution for this case? Okay, so let we derive the solution together. Okay, so firstly we can think that in this case we can use the depth first search, right? The DFS. And whenever we reach to we need to calculate the summation from every time we call the children. And then we need, whenever we reach the leaf node, and then we check the condition that whether it's greater or equal the limit or not. So in this case, right, it satisfies the condition, and we need to think about the value, the return value. So in this case, I suggest that we will use the true and false values to feedback to our parents, right? So in this case, for example, like we reach the value of 7, and this node will this node will notify to this node there. It satisfies the condition, and that will be the true. However, this node it will satisfy is it does not satisfy the condition, so we feedback with the value of false, right? So in this case, the parent node it knows that we need to delete this node. However, because like one of the pair of the children satisfy the condition, so that's why we need to retain the parent as well, right? We can do it, so on and so forth, because in here it will return the value of 2, for example. However, in this case, we will face with the problem. This one will, we will get the default value of the phones, for example, because this right child node is none, right? It may return the value of phones. And then in this case, because like the left child node return the value of 2, so we don't need to care about this. And then we still retain this node, right? Okay. However, in here, like let's say we still have the limit of 22, and then we have the special case like 10. Let's examine this tree, like, and then in here we have 9. So we can see that in here, like this part will feed back to the parent with the value of phones, and in here also the value of phones. So that is the reason why this tree is not satisfied the condition of greater or equal the limit value. So that's why we need to erase all nodes in this tree. So it means that in here we will return the value of none, right? Because in here we have the value limit of limit as 22, right? Okay, so let's make the code together. All right, so in here we need to define the function of the DFS with the root, and we need to pass the summation from the root to the leaf node, right? And so in here I will use the variable sum val, and then also I also need to pass the limits as well. And I will define the base case first because we are in the tree, so it is important to do the recurrence. And so I will define the base case. So my favorite in this case that whenever we reach to the leaf node, and then we will feedback, right? So I will root dot left is none, and root dot right is none, right? Yeah, so this is my favorite base case. So I just want to, I don't want to consider the none node, so that is the reason why I check the root dot left and root dot right. But of course, I sacrifice the running time in this case. So we need to check that if the sum var plus the root dot var, so it means that existing value in this part, if it is smaller than the limit, and then we will return the value, we will return the false. Otherwise, we will return 2, right? Okay, so for now, we go to the recurrence relation. All right, so for the recurrent relations, firstly, we need to update the existing value first by adding it to the value of the current node. And for now, I will create the default value for the left and the right at the phones, for example. Okay. So for now I will check that if the root dot left is not none, and then I will get the return from that node. So in here I will get the root dot left sum val, because we have already plus the root dot one in here. So it means that it is the current summation from the parents to the existing node. So in here we also pass the limit as well, and we also check if the root dot right, and we will get the return value of the child node. Okay. So for now we need to check that whether the children feedback with the value of phones or not. If that is phones, we will delete that node, right? So in here, like, we will check the if the left red, and then we will get the root dot left as none, right? We remove the node if right red, and then we remove that. Okay, so what should we return to the parent node? And for the parent node, we should return the left red or right red, right? Yeah, we need to signal to the parent node about the existing condition of the children, right? So it means that if we have the children like with the value of 2, it means that we also need to notify to our parents as well. So in here, like, so we finish the DFS, and for now we will call the DFS from the function. So in here that we will I will pass the 0 because like we will persist from the root, and then whenever we jump into any node, and then it will get the summation with the existing node. So I pass the value of 0 as initial value. and here that it be the limit. And then because the reason why I need to check get the red one in here is that, yeah, because of the special case, if the root node in here return with the value of the phones, so it means that we need to eliminate all of the nodes in the tree. So it means that we need to, yeah, in that case we just simply return the value of one of none to the because if we erase all the nodes in the tree, right, that would be none. Okay, so if red one is so, and then we will return none, otherwise we will return the root, right? Okay, so in here we pass all of the test case, and let's submit it. Yeah, so in here like we miss 100% of user with Python 3, but that is in terms of the memory. Okay, so thank you so much for watching my video. And if you find that my video is helpful, please give me a like or subscribe, and I will, yeah, create more videos in the future. However, for now, like, yeah, I am building the channel, so yeah, I am appreciated if you can give me a like or comment or anything. Yeah. So okay, thank you so much for watching my video again, and see you in the next video.